Okay, this is a very simple question. You have a system of two coils having a mutual inductance of 0.36 Henry. So this system over here, the mutual inductance is 0.36 Henry. Coil 1 and 1 is 12 turns, and it has a self-inductance of 0.82 Henry and carries a current of 5 ampere. I'm messing things up. The rush. Let me write it outside here. Coil 1 has 12 turns. It has self-inductance of 0.82 Henry, carries a current of 5 ampere. Coil 2 has 18 turns of wire. Okay, so they don't tell us which one is the primary one, which one is the secondary one, but not an issue. Okay, so now they ask you to find the magnetic flux through coil 1. So this one is asking for phi 1. Well, they tell the self-inductance over here. So you know that self-inductance is related to the number of turns related to the current using L is equals to N1 phi 1 over I1. Okay, this one is L1. Okay, so this is how you do question A. So 0.82, 12, 5.1, current is 5.0. So you should find the answer equals to 0.34 Weber. That is the magnetic flux through coil 1. Okay, so in this question, I'm not using mutual inductance, even though it's a mutual inductance setup, but you know that each coil will have their own self-inductance. So if you know everything regarding one of the coil and you're asked to find the magnetic flux, you can just use the self-inductance. Don't restrict yourself to mutual inductance. Okay, for the next one, they ask for the magnetic flux through coil 2. So now you have less information for coil 2, but you know you can relate it with coil 1, which you have most of the information. You know the system here, the mutual inductance is 0.36 Henry. So you can relate them together by saying that you want N2 phi 2, because this one they are asking for phi 2. Okay, you can relate the phi 2 and N2 together with I1. Okay, please remember that the subscript here must be opposite subscript. Okay, so over here you can put in N2 to become 18 phi 2. Current flowing through 1 is 5, then it's 0.36 Henry. So phi 2 will be equals to 0.10 Weber. Okay, lastly for C, if the current in coil 1 decreases from 5 ampere to 0, so means right, I initial is 5 ampere, I final is 0, and the duration is 30 milliseconds. Okay, let me write down here. They want you to find the induced EMF in coil 2. Induced EMF must be due to, in coil 2, must be due to change in current in coil 1. So you have to make sure you write the opposite one. So it's dI1 over dt. Okay, make sure induced EMF in coil 2 is due to change in current in coil 1. Change it into average form, and it becomes negative M delta I over delta T. So now it's just substitution. The M is 0.36. Final minus initial, 0 minus 5.0. The amount of time that has passed is 30 milliseconds. So if you put in everything inside, you should be able to get the answer to become equals to 60 volt. Okay, so this will be the induced EMF in coil 2. Okay, so that wraps up all the example I want to discuss for mutual inductance, and that wraps up the whole chapter 5, especially for self and mutual inductance. So that's all for this video. Thank you.